right, so now we're going to look at rational exponents, kind of go through rational exponents a little bit, but I want us first to look at this question. So I want us to use a calculator to evaluate -2 to the fourth and then put a parentheses around the -2 to the fourth. So this is something that a lot of people mess up on, so I really want you to understand what's going on here. So are they the same? And explain why this is true. If the exponent was odd, would the result still be the same? Explain your answer. Okay, so let's take our calculator here. And I just have this little basic TI 30. So if I were to put -2 to the fourth in there, it would be a -16. All right, if I put in parentheses -2 to the fourth, it's what? It's going to be a positive 16. So are they the same? No, they are not the same. Why do you think they're not the same? Why do you think that this -2 and then the -2 raised to the fourth are not the same? Okay, so you are raising the negative sign to the exponent in the second one. Okay, so would signs be opposite if they were an odd? So let's try it here. So it would be -2 raised to the third power, or -2 raised to the third power. And those are not going to be opposites, right? They are going to be the same. And the only reason it happens is because of that negative, okay? And negative times a negative times, a negative times a negative times a negative is still going to be a negative. And this one is on the outside, so it's always going to be a negative, okay? So, so if the exponent was odd, would the result still be the same? No, it would not. Raising a negative to an odd would be negative. Same as if there was just a negative on the outside. Okay? All right, so now let's look here. So we're going to start talking about rationals. So here I want you to find the square root of 1, 4, 9, 16, and 25. So I want you to use your calculator, and we know what these answers are, I hope, right? So the square root of 1 is 1, right? Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4, and square root of 25 is 5. Okay, so if I took the square root of each one of those, so the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. So I want you to kind of write that out for me so that you can just see what's happening here. The square root of 16 is 4, and then the square root of 25 is 5. So now I want you to take 1 and raise it to the 1/2 power. Tell me what you get. And 4 to the 1/2 power, and tell me what you get. 9 to the 1/2 power, tell me what you get. 16 to the 1/2 power, tell me what you get. 25 to the 1/2 power, and tell me what you get. Okay, so let me show you how to do that. So you'll say 1, and then for my calculator, you're still gonna just do that little caret top right there. See that little caret top right there? And then you're gonna do 1 divided by 2 up there. And make sure that both of those are in the numerator, or the exponent, I'm sorry. 4 to the caret top, 1 divided by 2. So it's gonna give you 2. 9 to the 1/2 power, is going to be what? 3. 16 to the 1/2 power. So let's do this. 16 to the 1/2 power is going to be a 4. 25 to the 1/2 power is going to be 5. So what do you notice about those two? So for A and B, what's happening? They're the same. Okay, so they are the same. So raising something to the power, the 1/2 power, and taking the square root, they are going to be the same. So basically, a power of a 1/2 is the same thing. As taking the square root. And I'm going to show you in just a second. Whoops. Taking square root. We're going to talk about that in just a second. Alright, so let's do the same thing. Let's find the cube root. My calculator actually has a operation. Your TI-83s, just don't have my TI-83 with me right now. You have a, on a math number, you have a cube root in there. So, or you have something that looks like this right here. See that little, that button right there? So I'm going to put a 3, and I'm going to use that. And that's at a cube root right there. So the cube root of 1 is 1. I have to put that 3 right there before I do mine. The cube root of 8 is 2. The cube root of 27 is 3. The cube root of 64 is 4. The cube root of 125 is 5. So what do you think is going to happen when you raise it to the 1/3 power? It's going to be the same thing, right? So very similar to what we did in number 10 up there, right? So 1 to the 1/3 power is going to give you a 1. 8 to the 1/3 power is going to give you a 2. 27 to the 1/3 power is going to give you a 3. 64 to the 1/3 power is going to give you a 4. And 125 to the 1/3 power is going to give you a 5. So what do you notice about those? Okay, so they're the same thing. So the power of a 1/3 is the same as taking the cube root. So what is going to be a rational exponent? So a rational exponent is just a radical sign. I'm just gonna skip down here real quick. So let's think about this. So if I was taking 4 to the 1/2 power, that's the same thing as taking root 2 of 4 to the 1st power, or root 2 to the 4 to the 1st power, like that. So the denominator on the rational exponent is the index root of the radical. Okay, so if I was taking 64 to the 1/3 power, that would turn into 3, root 3, 64 to the 1st power. Or it could be root 3, 64 to the 1st power, like that. Okay. So let's take a second and do these. Put these in your calculator and see what happens with them. Are they the same? So 9 raised to the 3 divided by 2 is going to give you a 27. 9 raised to the 3rd power, whoops, raised to the 3rd power, to get out of there, and that's going to be raised to the 1/2 power. It's also going to give me 27. So all these, I hope you notice that they are going to give you the same value. So 9 raised to the, whoops, can't do this correctly today. 1 divided by 2, get out of that, and then raise it again to the 3rd power. It's also going to give you a 27. So I hope you're seeing what the definition of a rational exponent is. So the denominator on that rational exponent, so really no matter how you write it, the denominator is going to be the index, okay, of your root, and however you write the exponent, however you want to write it. So if you want to take the square root of 9 first, right, or if you want to cube 9 and then take the square root of it, it's still going to give you the same answer, okay? So a rational exponent, so let's just say x to the a over b, can be rewritten as index b, x to the a power underneath the index, or b, x to the a, just like that. Okay. All right, so now I want us to do some examples of just using some rational exponents here. And I'm going to write these on my little whiteboard. Okay, so I want you to write it in simplest radical form here. Okay, so write this in simplest radical form. So I've got 16x to the 3/4 power. Not 3/4, I'm sorry, it's going to be on the outside. Okay, so this means that this is going to be the 4th root of 16x to the 3rd power. Okay, or this can be what? The 4th root of 16x, all of that raised to the 3rd power, just like that. Okay, so let's try to simplify this a little bit. So do I have a 4th root of 16? So what is 16? So 16 is 2 to the 4th power, right? Well, what is the 4th root of 2 right here? What happens here? Okay, so remember this is 2 to the 4th divided by 4, so this is just going to be a 2 on the outside, right? So let's think about this for a second. I can simplify it. Let's rewrite this again. So let's rewrite it as so this will be a 4 over 4 like that, right? And this will be x to the 1/4, right? So 4 over 4, 4 divided by 4 is just a 1, right? So this is going to be a 2, and then let's rewrite this again to the radical form. So the 4th root of x, and all of this still is to the 3rd power. Going a really long way about this here. So 2 to the, now I can say 2 to the 3rd, so now your rules of monomials here, so this is going to be to the 3rd, so 2 to the 3rd, and then this 4th root of x, this is also going to be to the 3rd power, but now remember you can write it on the inside as well. So this is going to be a 2 cubed, the 4th root of x, all of that cubed. So 2 cubed is going to be an 8. So this is going to be, a simplest form is 8, the 4th root of x cubed. Okay. Alrighty, so I'm going to change this one up a little bit. I like my whiteboard. Alright, so I'm going to, well, probably need to erase it. I need a little bit more room for that one. So I want to say 16x to the 4th raised to the negative 3/4 power. This is actually my son's little whiteboard that I took from him. Okay, so let's try to do this one now. So we've got a negative, so negative means that you can move this to the denominator, right? Like this, right? So now let's then rewrite this. So this is going to be the 4th root. Well, before we did that, what is, what's 16 right there? So remember, that's 2 to the 4th, like this. This will be x to the 4th. Okay, so now what could we do here? Instead of writing them in radicals right now, I can multiply the exponents, right? So this will be 2 to the 3/4 times 4. So what's going to happen to that? That's just like 4 over 1, like that. And this is going to be an x to the 4 times 3/4, just like that, right? So what's going to happen to these denominators here on the exponents? So this is just going to turn into 2 cubed and an x cubed. So this will be a 1 over 8 x to the 3rd. Okay, so far so good. Alrighty. So I want you to write this one in simplest radical form. And you may have never done anything like this before. So I'm going to try to kind of walk you through it. Just take you a second. So remember, all the indexes have to be the same, right? To write in simplest radical form. Okay, so the index roots always have to be the same if you're going to write it in a radical. So what does that mean that each one of those denominators need to be? So the denominators need to be the same, don't they? So to get the denominators to be the same, I need to find the common denominator. And the common denominator there would be a 12. So this is going to turn into 4 over 12. And this is going to turn into a 10 over 12. And this is going to turn into a 9 over a 12. Right? So now this is going to be the 12th root of 3 to the 4th power, m to the 10 power, and n to the 9 power. So they each go underneath that radical. And the last thing that I need to do is to turn 3 raised to the 4th power into, because I can't simplify any of these, so 3 to the 4th power is going to be an 81. So this is going to be the 12th root of 81, m to the 10, n to the 9th power. Okay? Alrighty. Now I want you to write using exponents here. This is 4, right? So I want you to use exponents here. Just get comfortable with rewriting them in exponent form. Alright, so it's in the denominator, so I'm going to move it to the numerator, and it's going to become a -7/5, right? Because this is your numerator and that's your denominator. Alright, what about this one? This one's the square root of 3x minus 5 raised to the 8th power. This is interesting here. So what's the index understood to be? It's understood to be a 2. So this will be 3x minus 5 raised to the 8th divided by 2. So this is going to be 3x minus 5 raised to the 4th power. Not too bad, right? You could multiply that out, but we haven't done that yet. So we'll get to that soon. Alrighty, so let's simplify here. Now I just want to simplify here. So the 4th root of 16, and there is a negative on the outside. So 4th root of 16. So 16 is what? Is 2 to the 4th power. right? So then this will become a negative 2 to the 4th divided by 4 like that. So it's just going to be a negative 2. Okay, what about this one? So I've got a square root of a 0.16. That's a decimal here. So 0.16 right there. So 16th is the same thing as saying 0.4 squared, right? And the same thing happens here. So 0.4 squared divided by 2. So that's just going to be a 0.4. I'm trying to get you comfortable without using your calculator. So I don't want you to rely on your calculator when you're doing all this. Okay? Just don't rely on your calculator. Alright, what about this one? The 5th root of 2 to the 10th power. 5th root of 2 to the 10th power. So this is going to be 2 to the 10th divided by 5. 10 divided by 5 is a 2. So 2 squared gives you a 4. Okay. Alright, we got a few more to do. Let's do a few more. Alright, so this one is, I'm going to say the cube root of 80. So the cube root of 80. Can't take the cube root of 80 though, right? So what is 80? Is there a, well, it's 8 times 10, right? So is there a cube root inside there? 8 is 2 cubed, right? 10 is just 2 times 5. So if I were to rearrange this, it would be 2 to the 3, and then it would be 10 to the 1/3 like that. 3 over 3, so this is just going to be a 2 times 10 to the 1/3. And then what do I do right there? Then I can change that back to the radical. So it's going to be a root 3 cube root of 10 there. I can't simplify that cube root of 10 anymore because the only prime factors there are just going to be 2 and 5. Alright, so now we're going to work on rules of exponents and radical homework. Alright, let me know if you have any questions.